Functions. A function is a correspondence from the first set, called the domain, to a second set, called the range, such that each element in the domain corresponds to exactly one element in the range. In general, the domain is your set of x values and the range is your set of y values. To find the domain of a function, think of the function as a machine, where you can take x values to plug into your machine. The machine molds that x value into a y value. So taking our function machine, this time letting our function be 3x plus 1, or f of x equals 3x plus 1. If we want to find the domain, or in other words, what are we allowed to plug into our function or to put into our function machine, we look at the specific function. Are there any limitations? Are there any type of numbers that might cause some trouble here? There aren't. You could plug in any positive number, you could plug in any negative number, and it's just going to pop out a y at the other side. So we can conclude that there are no limitations on what could be plugged in for x, and this function has a domain of all real numbers, or the interval notation of all real numbers is from negative infinity to positive infinity. We can say that all linear functions have a domain of all real numbers. On the other hand, if we had a function such as f of x equals 2 divided by x, this is a rational function. Basically, it looks like a fraction. That's what makes it a rational function. If we want to find the domain here, then what we have to remember is that there's no dividing by 0 ever allowed. We say that dividing by 0 is undefined. Since all we have is 2 divided by x, as long as we don't let x equal 0, we're going to be fine and there's going to be no clog in our machine. So our domain would be all real numbers except 0. We need to write this in interval notation, so from negative infinity to 0, union 0 to infinity. As I mentioned, this is a rational function, and for rational functions, the domain is all real numbers except the values of the variables which make the denominator 0. Now if we have a function, f of x equals the square root of negative 3x minus 5, this is a radical expression. Specifically, this is a square root function, so it has an even index. What we know about square roots is that if you take the square root of a negative number, it's not a real number. So we say you can't take the square root of a negative number, or more specifically, the square root of a negative number is not a real number. So we want to force our radicand. In this case, the radicand is negative 3x minus 5. We need to force it to be greater than or equal to 0. So you take the radicand and set it greater than or equal to 0. We're going to add the 5 to both sides. We're dividing by a negative 3. Keep in mind when you divide by a negative number, you need to flip the direction of the inequality. So our domain, or what we're allowed to plug into x, is from negative infinity to a negative 5/3.